Hey there, today we are going to practice naming angle relationships. So as you can see on the screen right now, we have all of these different types of relationships. In our last video, we talked about corresponding angles and vertical angles and linear pairs. And today we're going to name a few more relationships about interior and exterior angles of these parallel. Remember, two parallel lines are cut by what we call a transversal. If I line up their intersections, here we go, intersection 1 and intersection 2, if I pick it up and drag it, they'll line up perfectly. And we talked about how corresponding angles are those matching angles that would line up on those intersections. Okay, so let's go ahead and practice some of these other ones that we haven't heard so often. So first, make sure you draw this diagram in your notes. Notice I've got these two parallel lines and a third line that cuts the two in half. On my diagram, it's important to know, especially when we're naming angle relationships, what we consider the interior and what we consider the exterior. And if I look at this diagram, I can see that between, I'm going to highlight this in a different color, but between my parallel lines, so here are my parallel lines, we call that our interior, and outside of those parallel lines, we call it our exterior. And I would encourage you to label these. This is exterior, this is an exterior angle, this is interior, 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 exterior, exterior. So that's one of the main things that's most important to know about this diagram. The second most important thing to know, and I'm going to erase this for a second, the second most thing important to know is when you see the words same side, hey, what are they talking about? The same side of what? The same side of this line right here. So for example, I would say 3 and 4 are on the same side, 1 and 2 are on the same side, 7 and 8 are on the same side, 5 and 6 are on the same side. I could even say 6 and 7, they're on the same side. But I cannot say that 2 and 6 are on the same side because they're not on the same side of this transversal. Now remember, if my diagram flips around, notice now my parallel lines were running up and down, and notice here my parallel lines are running side to side. This is still my interior, this is still my exterior. And when we're talking about the same side, 4 and 5 are still on the same side of my third line that cuts them in two. So same side has to be on the same side of that single line all by itself. 2, 3, and 6 are also on the same side. Now that we've got that all settled, let's start talking about our angle relationships. So if you'll first draw yourselves a diagram that matches this one. Okay, we're going to draw a bunch of these today. And then label that same side interior, just so to the side. Same side interior. So this relationship has to have all of these characteristics. They have to be on the same side and they have to be on the interior. Now you know why I made such a big deal. So if I'm looking at my diagram, what are we talking about same side interior? Well, interior, so on the same side, here's my line that I need to stay on the same side. If angle 2 is one of my interior angles, well, what's on the same side, on the inside with it? Angle 3. So angle 2 and angle 3 are same side interior, and angle 6, I'm going to mark it with 2 angles because it's a different set of pairs, and angle 7 are same side interior. If I were to flip my diagram around, you'll see that this is the same. Okay, here's my line that cuts my parallel line in half. Same side of as this. 4 is an interior angle, and it's matching same side as 5. And 3 is matching with 6. Now, one important note to remember the other day when we were talking about angles and how we said that if I had two diagrams, two parallel lines, and this was, let's say this was 60 degrees. Remember, I could slide this down and this was also 60. Remember that other fact about inside angles. This is a line or linear pair. This angle right here would be 120, this one right here. When you add those two inside angles together, it totals 180 degrees. So we say same side interior lines are supplementary. And you'll see angle 4 and 5 add to 180, angle 3 and 6 add to 180. Okay, let's talk about a different pair. So we're going to draw another diagram and this time we're going to talk about the same side exterior angles. So same side, but this time the exterior. So I'm going to draw my line that I want to stay on the same side as, and I'm going to go to the exterior. So angle 8 would be on the exterior. Let's mark it with one little angle mark. What other angle is on the same side but on the exterior? Angle 5. And on the other side of the line, angle 4 is on the exterior, and what's on the same side but also on the exterior? Angle 1. And you'll notice that this also says supplementary. So angle 1 plus angle 4 is going to equal 180, and angle 5 plus angle 8 equals 180. If I look at a different diagram, even though I've got my line slipped, here's my line that I want to stay on the same side of. Angle 1 and angle 8 are both on the exterior. Okay, remember this is the interior. And they add to 180. And 2 and 7. So same side exterior. The next one I want to talk about is alternate interior angles. So alternate interior. And I would recommend continuing to draw individual diagrams for these so you can see them separately. So alternate interior. Now again, interior means I'm going to be looking on the inside of my parallel lines. So I'm looking in here at this section. Now think of the word alternate. When we think of alternate, we think of switching sides. Okay, we alternate our opinion, or we alternate a ball back and forth. Okay, we're switching. So when I'm talking about alternate in this diagram, and I'm going to go ahead and clear that circle that I drew in here, I'm going to go the inner section. So here's 6. Now, alternate interior. I need another angle that's on the inside, but it is not that is two things. Not on the same side as this line, so 7 is out. Okay, and it also cannot be on the same intersection as 6. So angle 2 is out, because even though it's on the opposite side of this line, it's still on this intersection right here. And when I say intersection, I mean where those two lines cross. So my only other option is 3. So alternate interior angles are angle 6 and angle 3. So I'm going to mark this a little more pretty and I'd like you to do this on your diagram. So 6 and 3. Now, are there any other pairs? Well, if I looked individually at 7, 7's also on the interior. What is alternate of it? So opposite side of this line, but it can't be on the same intersection. So 3's out for this pair, but 2 is also on the interior and it's alternate. These pairs are congruent. If you look at angle 6 and angle 3, you'll notice that they look the same size, and they are. Remember all of our diagrams, how we had those just two different sizes. They are congruent. It doesn't matter if my diagram shifts and rotates. If I'm looking at just the interior angles and I want them to be on alternate sides of this line, if I'm looking at angle 5 on the inside, the alternate on the opposite side of my line, okay, but on the second intersection is going to be angle 5 and angle 3, and 6 and angle 4. And you can kind of think about it, I kind of like to think about that they're diagonal from each other. So that's alternate interior. And they're equal to each other. All right. Finally, let's talk about alternate exterior angles. So alternate exterior. So alternate exterior angles. This time, remember, so if here are my parallel lines, exterior is outside of them. Okay, and if I'm talking about alternate, so if I'm looking at angle 8, alternate has to be on the opposite side of this third line. And it has to be on a different intersection. So 4 does not work as an alternate exterior angle because it's on the same intersection. It has to be on the completely opposite side. So angle 1 and angle 8 are alternate interior angles, and you'll notice that they're the same size. Alternate angles are also congruent. And if I looked at any other angles on my exterior, angle 5 and angle 4 are also alternate exterior angles. And again, it doesn't matter if I look at my parallel lines going the other way. Okay, here is my parallel lines marking interior and exterior. Here's exterior, here's exterior. Alternate sides, here's angle 8, also on the exterior, but not on the same intersection, angle 2. So angle 2 and angle 8, angle 1 and angle 7. And hopefully you're getting pretty good at recognizing these. Couple other things I just want you to remember: corresponding angles. So remember, if I were to cut my two intersections in half and slide one right onto the other, they're going to line up perfectly. They're congruent. Vertical angles we've already talked about. Remember those vertical angles? Or if I look at one intersection, those vertical angles are the ones that only touch at that point. So angle 1 and angle 6 are vertical, and angles 2 and angle 5 are vertical. Angle 4 and angle 7, and angle 8 and angle 3. A linear pair is a pair of adjacent angles. Adjacent means just next to. There are two angles that share a line. So 4 and 8 would be a linear pair. And no relationship is that there's no relationship formed. And you can see that it says that it's supplementary. Because remember, any pair of angles either are the same or they add up to 180. So let's practice naming what the relationship is. So first I'm going to mark up my diagram. Here are my two parallel lines. So this is exterior, this is exterior, 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 interior, interior. So I'm going to use that to help me identify. So let's go ahead and mark these up. Angles 1 and angles 3. Angle 1 and angle 3. Well, one's on the interior, one's on the exterior. So I can't use the any interior rules. But remember, they share this intersection. So we call these vertical angles. Angles 2 and angles 6. I'm going to clear this out. Angle 2 and angle 6. Again, one interior and one exterior angle. But remember, if I were to look at my two intersections, cut them in half, slide one down onto the other, two lines up with 6. When they line up like that, remember that's called corresponding angles. And I ran out of room. Angles 5 and angle 3. Okay, angle 5 and angle 3. This time they're both on the interior, so I'm going to write interior. And then I'm going to say to myself, okay, they're both on the interior. Are they on the same side of the line, or are they on alternate sides? And when we're looking at the same side of the line, we're looking at that line, cutting it in the interior in half. They are on alternate. So interior, alternate. 1 and 8. Ooh, 1 and 8 this time are on the exterior. So I write down exterior. You'll notice a pattern. If they're both on the interior, both on the exterior, that's the first thing that I write. So here we go. Exterior, and they are on the same side of this line. So alt exterior, same side. 7 and 8. Oh, they are both on the exterior, but they are right next to each other. Whenever you have two angles that are right next to each other, we call that a linear pair, or just supplementary. 1 and 7. 1, 7. They're both on the exterior, and they are on alternate sides of that green line. 3 and 6, they are, marking that up, on the interior, but they are on the same side of that green line. Interior, same side. And angles 1 and angle 6, angle 1 and angle 6, one's on the interior, one's on the exterior. Well, the only time I have that going on is maybe they're vertical. Well, they don't share an intersection, so vertical is out. Are they corresponding? If I were to pick this intersection up and set it, does one land on top of 6? No, so it's not corresponding. And a linear pair, do they form, are they on the same line? No, they're not even on the same line, so this would have no relationship. All right, let's practice using these rules to figure out angle measurements. So, notice it says in my diagram, suppose angle 1 equals 75 degrees, and I'm going to mark that 75 degrees. It says, we see that angle 1 and angle 2 are fill in the blank. Okay, we have to name our angle relationships. So, exterior, exterior, interior, interior, exterior, exterior. But I notice that they are on the same intersection. They're vertical of each other. So vertical angles. And thus, angle 1 and angle 2 are congruent. You're only going to have two choices here. They're either congruent or they're supplementary and add to 180. So therefore, angle 2 must equal, well, if they're the same number of degrees, 75. Okay, continuing. We see that angle 2 and angle 3, here's angle 2 and here's angle 3, we see they are, well, one's on the interior, one's on the exterior, so I can't write interior and exterior rule. But I do notice that if I slide one down onto the next, oh, but that does work. That means they are corresponding. And since the lines are parallel, 2 and 3 are congruent because they line up on each other. So therefore, angle 3 must also equal 75. They're the same size, so 75. Therefore, 1 and angle 3, oh, they're equal to each other. They are congruent. The relationship between angles 1 and angle 3 is an example of, okay, when they're both on the exterior and they're on alternate sides of this line, we call it exterior alternate. And that is it. If you have any questions, please reach out to your teacher. I know that these are a lot of names, so just keep referring back to the video. Hey, remember the first slide had the names. Jump back to the beginning. Make sure you have all of these written down. These are all of these written down. These are your options.